Okay, guys, today we're gonna keep with this idea of right triangle. Okay, so one of the angles has to be how many degrees? Okay, and we're typically gonna have 2 legs and 1 hypotenuse. Good. Okay, and this idea today we're gonna start talking about is named the tangent ratio. So when you were punching this in right here, what do you think tan is short for? Tangent. Okay. So what we're talking about today, guys, is a tangent ratio relative to, we're still using right triangles. Now, tangent has a lot of different meanings in mathematics. We're going to apply it to just right triangles today. The question we need to ask is, how is a right triangle used to find the tangent of what kind of an angle? Acute angle, so between what and what? Between 0 and 90 degrees, yep. It says, how is a tangent function used of an acute angle? Is there a unique right triangle that must be used? And the answer to that's going to be no. So goals today, we're going to use the tangent ratio and then look at some problems that involve the tangent ratio. So let's make sure we can understand this. Again, what kind of triangle are you working with, kiddos? Okay. You're going to be working with a right triangle and you'll have some acute angles to it. Okay. So let's get rolling on this. First things first. What's a term-wise here? It's kind of for it. Trigonometric ratios. Now, kids, I don't know, year or two, you're probably going to take ACTs. Is that true? Okay. I can tell you right now, and I've said this over and over and over and over, and it's been a good thing for the kids the more that we preach it. For trigonometry, we offer trigonometry as a course here for a whole trimester. Okay? You're going to start getting a little basics that would help you get into that course. But I will tell you this, the next 3 sections that we look at are very important in terms of probably doing well on the math part and or on the ACT move forward. I think if you can get yourself in a position down the road to take trigonometry as a class, which would be after college prep for you guys, or maybe even take it next year while you're taking college prep, any trigonometry you put behind yourself, that just boosts your ACT score in math. Okay? So here I am. I'm not trying to sell you anything. I'm just telling you that if you want to do better in the math part of the ACT, maybe be a good course to think about. Trigonometry. We're going to start touching just on the very basics of that today. Okay? And we're going to talk about, first of all, trigonometric ratios. It says a trigonometric ratio is a ratio of the lengths of how many sides of a right triangle? 2 sides. So what we're talking about, kids, is this. Okay? In a right triangle, we might have the following. And you've kind of done this already. I'm going to abbreviate some sides here. I'm going to call this a leg. Maybe, I don't know. I'm just going to call this a leg 1. Leg 2. I'm going to call this my hypotenuse right up here. Okay? First of all, how many sides to a right triangle? 3. Okay. Trigonometric ratios are formed by using how many of the 3 sides? 2. So what they might be saying is this. You might be comparing the length of leg 1 to the hypotenuse, or you might be comparing leg 1 to leg 2, or you might be comparing leg 2 to the hypotenuse. But the idea is it's a ratio comparing how many sides again, kids? Okay. All right. So let's talk about specifically today. There's 3 different ones. You guys see another button like tan in your calculator? And that's, you see other like 3-word ones right by the tangent function?
Sin.
Yeah, sin's the naughty button on the calculator, okay? Cost, I said so. Cost, I said so. Oh, never mind. Sin actually stands for sine, and that's going to be a different one. But sine, cosine, and tangent are the 3 basic ones we're going to talk about. And today we're just dealing with tangent, but we're going to use those sine buttons and those cosine buttons a lot the same way we're going to do the tangent today. Okay. So those buttons are there. They're all trigonometric ratio buttons. Let's talk about what a tangent is. First thing I'm going to have you do is draw a right triangle. Okay. Let's make our right triangle like this here. Oh, I better get myself some room to write. That'd be good. And then put your right angle right down here, kiddos. Okay. Anybody want to read that definition of tangent for me once you've got your right triangle drawn? Go ahead.
The tangent ratio is trigonometric
There you go.
ratio for acute angles that involve the lengths of the legs of a right triangle.
Okay, so the tangent here, guys, is going to involve the what? Okay, so it uses the legs of a right triangle. Okay, so if I labeled my sides A, whoops. Uh-oh.
Oh, is it dead? Is it broken?
I don't know.
That's what's wrong.
Fixed it.
Oh,
Okay.
shoot.
I had a backup plan.
What was that?
Use the little pad over there. Okay, if I had sides A, B, and C up there, which two sides is the tangent ratio going to care about? Which labeled sides?
A and B.
Okay, it's going to care about A and B. So the tangent would use lengths A and B, and I'll show you some examples how that's used here in a second, but just understand this. You ever see the word tangent? From now on, involving right triangles, what two sides of the triangle are you focused on? And notice A and B represent my two what? Legs. Okay, so we're going to talk about that legs a lot. All right, two sides that form a right angle. All right, last vocab word before we start talking here, kiddos. It's called an angle of elevation. It's an angle that an upward line of sight makes with a horizontal line. It's called the angle of elevation. Have you guys ever taken, like, I don't know, have you guys ever used, they're almost like binoculars, and they have a little measuring compass on them, where if you look up, it can tell you what angle you're looking up at something far away. Never used those before? We'll have to check it out, maybe. I think we've got some here. We might have to see if I can dig those up and find them. Angle of elevation is like this, okay? If you had a horizontal line right here like so. Okay, so if I said look straight ahead, I would say if you're looking straight ahead, you would assume your line of sight is what kind of line?
Straight.
Yeah, it's horizontal, right? Okay. So this might be your line of sight. Okay. Let's say that you're standing right here. That's where your eyesight is. And all of a sudden you look to a point up here. Okay. And all of a sudden your eyesight goes from what you were looking straight ahead at to a point right up here maybe. Okay, so from when I was looking straight ahead to when I looked up, what do you think I formed right there? Yeah, this triangle. My eyesight was horizontal, now it's looking up. What do you think we call this angle right in here? It's the angle of elevation. It's an angle that an upward line of sight makes with a horizontal line. And it's called the angle of elevation. This is my horizontal line right down here at the base. Okay? The line as I'm looking up, or my upward line, isn't this the line that's kind of pretty much moving upward here as I move to the right? Well, yeah, it'd be an uphill line basically is what it is. And that's where your angle of elevation would happen right in there. All right? Okay. Don't worry about that too much. The big idea is this tangent involves which two sides of a right triangle?
Legs.
Legs. And they're going to involve the legs. All right, let's get into this core concept. Now this should say tangent ratio, not tangent ration. I just made a mistake typing it. Okay, all right. This says, first of all, in this core concept, let ABC be what kind of a triangle? It's a right triangle. Okay? So let's draw in a right triangle. Now let's do this. There's my right triangle. Okay? And I'm going to label this A, B, and C, just like this.
On the point?
Okay. Okay, it says the tangent of angle A. Now, what I want to tell you right here is this, because this is very important. Okay, how many different angles are there in that triangle? Which angle is my right angle?
B.
All right, here's the deal. anytime they tell you the tangent of a certain angle or a certain degree number, it's kind of like saying, if I'm dealing with the tangent of angle A, it's kind of like saying you are at one of these 3 points. And specifically, they're telling you you're standing on which point. Okay, you are here. Okay, when they say tangent of angle A, basically everything references from this vertex right here. It's basically saying that that's where you are standing to start with. Okay? All right? Now, what that says is this. It says the tangent ratio is the leg that is opposite of A compared to the leg that is adjacent of A, or leg opposite over the adjacent leg. Okay? Guys, I'm going to call this leg 1 over on the left, leg 2, like so. Those are my 2 legs. My question is, which one of those legs, 1 or 2, is opposite of angle A? In other words, across from it, or not touching it. Leg 2 is, right? Adjacent means it's the one that A is actually touching leg 1. That's adjacent. Okay, so what's my opposite leg length again, kids?
2.
Leg 2. Leg 1 would be the... Okay, so I like to label leg 2. I'm going to call this the OL, which stands for, what do you think?
Opposite.
And I'm going to label this AL, which stands for what?
Adjacent.
Okay, and the tangent of that angle would be whatever this leg is down here lengthwise, opposite leg over adjacent leg. Now again, this letter A right here is important because this tells you what?
Where is the...
Okay, let me ask a question. What if I would have said tangent of C? Would that be the same thing? Or would that be something different? Which leg is opposite of angle C?
Leg 1.
Leg 1. And then which leg is adjacent to C? Okay, so let's talk about this in terms of what we need to accomplish. Everybody have what you need, first page?
I have a question.
Yeah, buddy.
So how do you know which one is 1 and which one is 2? Like,
Doesn't really matter. I'm gonna go away from leg 1 and leg 2 right here, Olivia, and start talking in terms of what's the opposite leg and what's the adjacent leg. Okay?
Okay.
So the first thing, and you'll see that on the next example here, I
Okay.
think. Okay, let's just try to see if we can answer that question with this next example. Okay, here's the deal. It says find the tangent of A and B. Write each answer first of all as a fraction and then as a decimal rounded to how many places? Okay, the first angle I'm worried about is what, kids? Tangent of angle A. So I'm going to write tangent of angle A up here. So that's basically saying, okay, go jump on what point, kids? Or go stand on which point? Okay, you are on A. All right? I'm going to ask a question. If we're only involving tangent, what length don't we care about? So what do I not even care about here? I might as well just get rid of 39. We're not going to use that thing. Tangent of angle A, kids, you are here. And by definition, I'm going to write it down again. I'm going to write T equals, I always put O over A like this. What do you think that means? Opposite leg over adjacent leg. Okay, I like to call it OL over AL. Hey, you're at angle A, kids. What's the opposite leg to A? Is it 15 or 36? Which one's across? Okay. Opposite means it's not touching the angle. So which side is opposite not touching this angle A that you're at? It'd be 15 over what? The leg that's touching angle A is 36. Now kids, here's the deal. They also want that to 4 decimal places. So in your calculator, just go 15 divided 36. .4167 then about, if we round correctly. Okay, now I'm going to tell you what this means. All right. Do you guys agree that .4167 is the same as .4167 over 1, kids? Don't write the over 1 part. Do you agree with that? Okay. Here's what this is really telling us. This is telling me for every .4167 units of my, what's up top, so every .4167 units I measure on this line, right here, or this side across from the angle, I'm measuring how many units on the side adjacent. So if I gave you, I'm gonna go 0.4167 units here, I'd have to go one up here to keep this triangle consistent. One whole unit. That's what that's really telling me. Okay? All right. Well, how does this change then if we go ahead and talk about not tangent of angle A, but stand somewhere else? Say, for instance, tangent of B. Okay? All right. So instead of standing at angle A, where are you now standing? You're down here. So which of the two legs is across from angle B, or opposite? 36 over what? 36 over 15. Now, kids, I'm gonna be honest with you. Could I simplify that ratio right there?
Yeah.
3 would go into both, wouldn't it? Would be 12 over 5. I'm not necessarily going to tell you you have to do that. What's that divide out to be?
2.4.
That's a pretty nice one, isn't it? Do I even need to go 4 places on that one? Okay. So what it would mean is this. Like, think of it this way. This is like 2.4 over what value, kids? Means up here, means if I'm standing at B, for every 2.4 units I go up here on this line, I have to go how many units on this one? 1. Okay, that's what that's telling me. All right. So if I say here's a triangle with 3 different sides in it, can you give me a tangent ratio of the given angle that you're at? And you would say, well, I got to figure out where I'm at first, and then do what over what, kids? Opposite leg length over adjacent leg length. Okay, I think we're okay on this. Give me a show of hands. How many are on board with these two right now? Okay, again, does it matter where I start? Absolutely. Okay. When I say tangent of A, it's like saying, okay, we're going from this point. You've got to say we're referencing everything right there. All right, example 2. Put a star by this right now. This is one that I'm concerned about. Holy moly.
What's the tangent key on the calculating formula?
I'm going to tell you real quickly. Okay. Olivia, did somebody like program you today to ask all these questions? Because your questions have led right into the next example.
No.
No? Well, just pat yourself on the back because you're asking great questions today, all right?
Oh, thanks.
Guys, take a look at the triangle in example 2 and compare it to the triangle that we just looked at in example 1. What's different about this?
It doesn't have all the numbers.
Don't have all the sides.
A, B, C.
A, B, C, not up there. Okay. What do we have that we didn't have in example number 1 up there? Okay, here's the deal. This is a giveaway to start something. I'm going to highlight this right here. A lot of times right here. First of all, label this down here as X. Okay. First question, hear me out. Are we still dealing with a right triangle? Yes. Okay, but the thing that you notice here this time, inside the triangle there is a degree measure, right? Okay. Now kids, have we talked about any special triangles that have 25 degrees in them before? No. Okay. And this is why we start using the tangent function. This is where your tangent button is going to come into play. But here's the deal. Kids, they give us a right triangle and they tell us that this leg over here is how long? 12. And they say that this leg is unknown. This is what we're trying to find down here, right? Okay, so here's how this works. First of all, first thing you always want to do is this. If you ever have to find a length up here, if you ever have to find a leg length, first thing you're always going to do is find what I call a reference angle. Find a reference angle. Okay? In other words, other than the right angle, is there an angle that we know the measure of? What did we highlight here? What degree measure did we highlight in there? Okay. Basically, we're saying, kids, this. We're pretty much telling ourselves that this is the angle that we're standing at right here. Okay? You are standing right here. Okay, we are referencing right here. I'm going to put RA down here because that's going to represent my reference angle. Right? All right, kids. In relationship to my reference angle, how is 12 related to that angle? Is it an opposite leg or an adjacent leg? If I'm standing right here, 12 is an, okay, so I'm just going to write down here OL. Okay, and that means then that X would be what kind of leg right here, kids? X is my adjacent leg. Okay, here's how this works, kids. All right. Instead of calling like up here, we named our angles like A, B, and C up here, didn't we, in example 1? We're not doing that anymore. We're not going to use a name for the angle anymore, but we're going to use the degree measure on this. Okay? And here's how we set this up. Step two is to write an equation. Write an equation. Here's how this works. Instead of saying like tangent of A, B, or C, we come down here and say, okay, we're going to use the tangent of, I don't have a name for it, but we have a degree measure where we're at. What is that degree measure?
25.
Okay, we're going to come down here and say the tangent of 25 degrees. Now, guys, the reason I'm using tangent is because we're using what and what here? Opposite leg and adjacent leg, and that's what defines tangent for us, okay? So we say the tangent of this 25 degree angle, this angle right down here, the tangent of this 25 degree angle is equal to, by definition, the opposite leg length, 12, over the adjacent leg length, which is x. Now, this is where things get pretty cool. Remember the example up above? It said, take your decimal out to 4 places. This is where your calculator comes in handy. Go into your calculator. Type in tangent of, how many degrees do you think, kids? 25. Type in tangent of 25. That tangent of 25 is a trig ratio. It's going to give you some value. You're saying there's some value to that. So when you punch in tangent of 25 degrees, what does that kick out for you?
4.663.
Say it one more time.
0.4663.
Okay, 4663. Now, kids, when you're doing these ratios, I think 4 places is pretty good, unless it comes out exactly for you, okay? They're saying that tangent of 25 degrees is equivalent to 0.4633, or 4663, okay? Anytime I do these decimals right here, kids, I always put it over 1, okay? All right, so the part that I'm underlining right here, tangent of 25 degrees, do you understand how we turned that into 0.4663? Okay, then that has to equal a ratio of 12 over what, kids? And just think about it. This is saying right here, okay, relative to this angle, for every 0.4663 units across, there is 1 unit of length that's adjacent to this, okay? This tangent of 25 got rewritten as 0.4663. It's still equal to what ratio, though, kids? And guys, by putting that over 1, don't we simply form a proportion that we can cross multiply and divide? By the way, you think x should be longer than 12 or less than 12? What's it look like in the picture? Okay, let's just see if that happens. So run 12 by 1, divide 4663. I think for lengths, this one here says find our answer nearest 10th here. So this is, from this right here, what do we get for x?
25.7.
25.7. Do they have a unit on there? Nope. Okay. What do you guys think? Yeah, you would go 12 times 1 divided by what here?
No. And then you just do 12 divided by x.
Yep, you can do that.
Oh, you just have to find the value.
Just got to find the length of that.
Oh,
That's it.
okay.
I have a question right here. Once I knew x was about, what did we say here?
Well, that length happens.
All right, listen to this right here. You want to see something wild and crazy? Do this for me. Somebody take 25.7 right here. Take 25.7 and divide it by 12.
2.141.
So it's at 2.14, about like that. Okay, watch this right here, kids. If I had this is 90 degrees, right? And this is 25. Could I figure out this last angle up here? So what's 90 and 25 add up to?
115.
What's 115 from 180? 65 degrees? So opposite of 65 degrees is what? 25.7. Adjacent is what? 12, which we said divides out to be about what? In your calculator, type in tangent of 65 degrees. See if you get. Type in tangent 65 degrees.
4, 5.
Okay, so they've already figured out these ratio lengths for all these angles. Somebody sat down and went through all these. They said, if I have a 65-degree angle, they measured this side, they measured this side, divided them out, and they said, okay, for every 2.1416 units on the opposite leg, I've got one on the adjacent leg for a 65-degree angle. Okay? So, Olivia, I'm going to come back to you. Does that answer your question? When do we punch the buttons?
Yeah.
Does that make sense?
Yeah.
I want you guys to try this one on your own. I'm going to put a triangle right up here. Is there room on the very back side of your notes?
Yeah.
Try this one. Ooh, red doesn't show up very well, does it? You guys try this one up here on your own. I'll draw it up here for you. Right triangle. Try and trick you on this one. Somebody give me an acute measure, angle-wise.
35.
35 degrees, I heard? Somebody give me a leg length.
12.
12. Pick something other than 12. We already had 12.
23.
23. Okay, that's what I'm giving you up there. All right? Find your reference angle. Set up an equation. See if you can't find the length of x. Just the way I've set it up, does it look like x is going to be longer than 23 or shorter than 23? Looks like it might be shorter. Why don't you go through the work and confirm that, all right? Take about 3 minutes and 14 seconds, and when you've got an answer, check with someone around you. If they don't agree with each other, talk to some people about why you disagree, okay? You said everybody was here today, right, guys?
I got 30.
Which side is opposite of this thing? X should go on top, and 23 should go on the bottom. Okay? And that's a common error right there. We're going to talk about that, all right, Logan? Yep. So you have a pod for that? Question?
Joke.
All right, done or not? Anybody wants to volunteer to talk me through this right now?
Yeah.
Okay. You said
You
yeah.
need a tangent of 35.
Okay, so you're referencing 35 degrees right here, right?
Yeah.
All right, tangent of 35.
And that's going to equal x over 23.
Why not 23 over x?
Because x is the opposite.
Yeah. So you got to make sure you're saying, okay, if I'm here, which side is opposite of that, kids, first? What's across from it? X, and now what's adjacent to it or touching it? 23. Okay, I saw a couple 23 over x's, so be careful on that. That's a common mistake. All right, so this is the part where you go on your calculator and you punch in tangent of 35 to how many places? Which is about
0.002. You didn't ask.
And I tell you, I think it's really important every time you turn that trig ratio or that trigonometric value into a decimal, I think it's important to put that decimal over what every single time? Put it over 1 every single time. Guys, cross multiplying and dividing, what did you get for an answer to the nearest 10?
16.1046.
See one more time?
16.1046.
So about 16.1? All right. I love it. How many had about 16.1? Okay. Reference your angle, write your equation, change your trigonometric function into a decimal, cross multiply, divide. That's all you really need to do when you're solving for a side. Okay. So let's talk about example 3. Questions about that at all? Somebody said something just now. Is it good? All right, well, let's try this next one right down here. It's about done here. We're going to get this done perfectly. Okay? It says use a special right triangle to find what, kids? Okay? Right triangle right down here. Now, kids, we know a thing or two about the tangent of a 30-degree angle. Watch this right here. Remember dealing with 30, 60, 90s? Happy memories, right? Okay, if I said this distance right here was 1, what's that make the hypotenuse then? Short leg times what to get the hypotenuse? Times 2, so this would have been 2. And then the short leg times what got me the long leg? 1 times the square root of. So this would have been 1 times the square root of 3, right?
Yup.
Let's just talk about tangent of 30 degrees here, kids. In this triangle right here, which leg is opposite of my 30-degree reference?
No.
What's the long leg or adjacent leg length then? Root 3, right? Okay, now watch this right here, kids. Here's what I want you to do. In your calculator, take 1 and divide it by the square root of 3. Take 1 and divide it by square root of 3 for me in your calculator. If you go 1 divided by square root of 3, what do you get for a value? 0.5773. If we rounded, okay. Now do this for me. In your calculator, type in tangent of 30 degrees. Anybody want to guess what that might equal?
Probably the same thing.
Check it out and see.
You know what?
When you punch in tangent 30 degrees, what's it kicking out decimal-wise? 0.5774. Okay, again, what this means, kids, is this. It means this. I'm going to kind of draw this as best I can. I'll highlight maybe a little red right here. It means for every, that red unit right there is 0.5774 units right there. If that unit's 0.5774 units, for every 0.5774 units I have on this opposite leg, how many units do I have on the adjacent leg? 1. Okay, that's what that means. You guys have got this, I think. I feel pretty good about this, all right? Let me know when you have that. We'll get this last example done. Anybody need more time, page 2? Are we good? Got it, Deanna? Good? Okay. Last example then, let's talk. Holy cow, it's kind of a big one.
Got plenty of time.
Okay, it says you're measuring the height of a, what here, kids?
Tree.
Okay, so I'm going to kind of put some art in here. Don't laugh at my art. My art's about as good as my English. It ain't so good. There's my tree at the top. Okay, and then this will be my, well, I'm going to pick brown. Is brown up here?
Yeah.
Wait.
It's right there in the corner on the right.
Is that brown?
Here?
Yeah.
That'll work, won't it?
Oh wait.
That's all right. Here's my tree trunk.
Oh, so if it says you're standing at 40 feet, does that mean that you're on the short leg? On the
Yeah, pretty much.
hard seat?
Hey, here's my big tall tree. Says you stand what, kids?
40 feet.
So what they're saying is this. This is where the base of the tree is at the ground. You're standing how far away from it? So you're standing pretty much right here, right? Okay? So I'll draw a stick person because that's the only kind of person I know how to draw. All right. Let's see.
They can have curly hair.
Curly hair. Ooh.
Like, probably green hair too.
So you're standing right here, right?
Oh, that's a little wonky. Oh, yeah.
What the snark? Yeah. Come on. Rapunzel, and now you're here. All right, stop parsing. That was
Rapunzel
not.
has straight hair.
Does she?
Yeah.
Ah, shoot.
And it's longer.
Is it longer than that?
It's way longer.
Like that much?
Probably like the size of the tree.
Oh, you're probably right. Okay. All right. So how far is this distance down here, kids?
40.
Okay. Now we've got to make some assumptions about this problem, kids. When we talk about the tree, we probably assume the tree grew straight up. So the angle made with the ground and the tree, we want to assume probably what kind of an angle. Okay, so we're assuming a right angle right here, right?
Well, that's what we assumed.
Okay. Says the angle of elevation to the top of the tree is what? Okay, where do you think you want to put that 65-degree angle
At
at?
the top.
Okay.
I think it's by her face.
Okay, so the angle of elevation is always like from your eyesight. Okay? So it's like if I'm looking straight ahead and then I look to the top, what angle did my eyes, how many degrees did my eyes shift up to look at the top? How many degrees did it, okay? So the angle of elevation is always basically from where you are. So the 65 degrees should go right, whoops.
I'm gonna make the tree.
65 degrees should go right about there. Okay, what are we trying to find?
The height.
Height of the tree, which is right here, isn't it? Okay. Just talk to me about this then, kids. Our reference angle is going to be what measure? Okay, so we're referencing everything from here. So what's the opposite leg? H is going to be the opposite leg. What's going to be the adjacent leg? Okay, help me write an equation then for this reference angle.
Yeah, 65 degrees.
Tangent. 65 degrees.
Is 8 over 20.
H over 40. Opposite leg over adjacent leg.
You know, we can.
All right, somebody want to run tangent 65 to 4 places? Should be 1 point something. Or maybe 2 point something.
1.445.
Say it one more time.
2.1445.
I personally think
Probably a good idea to put this over what?
1.
Do you guys expect that this tree will be higher than 40 or?
Higher.
Okay.
85.78 feet.
So when I cross multiply and divide there, I've got a height of about
85.
and depending on how you round, it's okay there. All right. Now, kids, I did send out a new outline. That'll be the first thing I try to start looking at. Wednesday midnight, when that'll be due. Don't forget quiz corrections. If you're going to make quiz corrections, what's the deadline for that? Okay, and then please do me a favor. Get into JMC, look around, see what you might have missing. Questions on anything? Feel pretty good about this today? Okay. You want to know what's cool about this stuff? You know all the other triangle stuff we've been doing? We can apply that to some of the other things we're
Can I
doing.
get rid of all my notes?
Not in chapter 9, I wouldn't, if I were you, because we've still got to take a test there. But 5 would probably be okay, Ellie.
I have all my notes since the beginning of the school year.
That's good.